All right, 1998 AP Calc AB, multiple choice part of the exam in this video, the no calculator portion. Let's begin right away, okay? I solved the problems already, most of them, and it's pretty easy. Well, in my opinion, it's pretty easy. Nothing tricky or super hard conceptually, from what I recall, okay? What is the x-coordinate of the point of inflection on the graph, this guy? Point of inflection, that should signal second derivative, okay? So if this is y, let me see if I can squeeze it in at the top here. Y prime is, we just use the power rule. It'll be x squared plus 10x, okay? And second derivative, we differentiate that. That would be 2x plus 10. We set it equal to 0. The critical point is x is equal to -5, okay? So we can go ahead and circle that, but it's better to check that it's actually a point of inflection, okay? So we do the second derivative test. We plug in some number much less than -5. This guy would be negative. Plug in some huge positive number, okay? That's because that's on this interval, okay? Some huge positive number, this would be positive. So we confirmed it's a point of inflection because the second derivative changes sign. Graph of a piecewise linear function f is here for x is between -1 and 4. What is the value of integral from -1 to 4 f of x dx? Integral is area under the curve. So we're going to add this area and we're going to subtract this area of this trapezoid here. Okay, so how do we find area of a trapezoid? It's average of the bases times the height. So this guy, this trapezoid up here would be, well, this base is length 1, 2, 3. The top base is length 1, divided by 2 times the height, which is 2. Okay, and then we subtract the area of this trapezoid. So this base here is 2. This base here is 1. Okay, divided by 2 times the height, which is 1. Okay, this is what? 4 minus, this is 3/2, or 4 minus 1.5. So it should be 2.5. Okay, we have this integral from 1 to 2, 1 over x squared dx. This is just simple power rule. It'll be -1 over x. Evaluate from 1 to 2. Okay, we just did the power rule. This is what? -1/2 minus 1, which is negative of -1/2, which is 1/2. Okay, moving on. If I can flip the page, I always have trouble flipping the page. If f is continuous for x is less than, or x is greater than equal to a but less than equal to b, and differentiable, this is probably key, continuous differentiable for x is between a and b non-inclusive, which of the following could be false? Okay, what does this first one say? F prime of c is f of b minus f of a over b minus a for some c such that c is in between a and b. This is mean value theorem. Okay, so this is fine because f is differentiable and continuous. Okay, by the way, if it's differentiable on this interval, it's automatically continuous on this interval. Okay, so they had to probably write it like this because there's maybe a difference between continuity, including the endpoints, and differentiability, not including the endpoints. So let's see. That's what I'm thinking. F prime of c is equal to 0 for some c such that c is between a and b. This is trying to apply Rawls' theorem, it sounds like, but f of b needs to equal to f of a for this to be true. So this is probably the answer. So let me check. That is right, okay? But let's look at the other choices. F has a minimum value on this interval. This is just saying there's absolute min. So this is, of course, true. Whenever it's a closed interval, there has to be an absolute min. Same thing for max. There has to be an absolute max. And this one just says integral from a to b, f of x dx exists. This is true because we know that f is differentiable. Okay, so this is fine. Okay, we have this integral from 0 to x sine t dt. How do we solve this? Well, let's just treat it like normal limits. X is just some variable. Okay, so we integrate sine, find the antiderivative of sine, that's minus cosine t. We evaluate from 0 to x. Okay, so that is negative cosine of x. Okay, minus parentheses negative cosine of 0. So this is negative cosine x. Cosine 0 is 1, so negative 1's in the inside, but we have a negative out here again, so it becomes plus, or 1 minus cosine x. If x squared plus xy is 10, then when x is 2, dy dx is what? We have to implicitly differentiate. Let's see if I can fit it in. Derivative of x squared is just 2x. Derivative of this guy, we need product rule first, d second plus second d first. First, d second derivative of y is dy dx, plus second, which is y, d first derivative of x is just 1. Okay, and then derivative of 10 is 0. Okay, so we solve for dy dx. dy dx is equal to, well, I would have to move this 2x and y to the other side, minus 2x minus y, and then we divide it by x. Now we evaluate it at 2 comma, what is the y coordinate? Because this is in terms of x and y, so we need a y. So when x is 2, let's plug it into here. It'll be 4 plus 2y is equal to 10. So it looks like y is equal to 3, so 2 comma 3. This is equal to minus 4 minus 3 over 2, which is minus 7 over 2. Okay. We have this integral from 1 to e, x squared minus 1 over x dx. So let's just divide through with the x. Divide through by the x. Okay, so it becomes x minus 1 over x dx. Now this is easy to evaluate. This is just x squared over 2 minus log of absolute value x, evaluate from 1 to e. So this is just e squared over 2 minus ln e, which is just 1, minus parentheses, we plug in 1, we get half minus 0. Okay, so it should be e squared over 2, this is e, okay, sorry, minus 1 minus half, that's minus 3 halves. So 7 is E. Let f and g be differentiable functions with the following properties. G of x is greater than 0 for all x. F of 0 is 1. Okay? If h of x is f of x times g of x, and h prime of x is f of x g prime of x, then f of x is equal to what? Okay? So here, this one you have to think a little bit, okay? When it says h is the product of two things, okay? H prime, I thought also maybe it's product rule that we have to use, but we don't even have to do that because I see that only g is differentiated. F is the same. So it's like when we differentiate, for example, 3x squared, this is, if we differentiate this is the same thing as moving the 3 out, and then we differentiate x squared. Because 3x squared is a product of 3 and x squared. So it seems like f is a constant. So let me write that. Okay? So if f is a constant, we know that f of 0 is 1, so f is 1. Okay, let me double check that's the answer. Should be 8e, yes. Okay? So that's how I thought through this problem. So, not too bad. Okay. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above of the following, which best approximates the total number of barrels of oil that passed through the pipeline that day. This is a rate, and we want a quantity, so we have to integrate. Okay, so we got to find the area under this curve. So we just could, this is just approximation, so we can count. If this is 600, one box is 600, we have how many boxes? 1, 2, 3, and these two are kind of half, so 4. So 4 times 600, that is 2,400, okay? But is it actually 2,400 or is it a little more? Okay, that's what I immediately thought. So let's see. So we can already eliminate this, this. Okay, so it's probably one of these, but let's keep this also. Okay, so let's have a better approximation now. All right, so, oh, actually, did I just miscount? It's 1, 2, 3, 4, and then 4.5, 5, because these are 2 halves. So 5 times 600 is 3,000. So it should be this one. Okay. So for sure it's not this because it would just be around these 4 boxes, but then we still have these 2 halves up there. So that's the next one, 3,000. Okay. So that's how we quickly can do that. What is the instantaneous rate of change at x is 2 of the function f given by this guy? Okay. Instantaneous rate of change, that's the signal derivative. So we want to find f prime of 2. That's what we want. Okay, so let's find f prime. Let me do it up here. We need the quotient rule. F prime is bottom, d top, derivative of top is 2x, minus top, d bottom, derivative of bottom is just 1, over bottom squared. We evaluate this at x is equal to 2. That's what we want, okay? And so what do we get? We get 2 minus 1, which is 1. 2 times 2 is 4, so we have a 4 there. Minus 4 minus 2 is 2. Times 1 is still 2, okay? Over bottom square, we get 1 squared, which is 1. So the answer is 2. Okay? So let's see. F is a linear function, and 0 is less than a, less than b. Then integral from a to b, f double prime x dx is what? Well, if f is linear, so it's like ax. Okay, let me use, I wrote it on the wrong area too, but let me use some different variables like mx plus n. Okay, if this is f. What's f double prime? Well, f prime would be m. F double prime would be 0. So we're integrating from a to b of 0 dx. So what is that? That's just 0. If f of x is ln x for x is between 0 and 2, and including 2, but not including 0, x squared ln 2 for x is greater than 2, less than or equal to 4. Then limit as x goes to 2, f of x is, this is a piecewise function, so we have to take limit from the left and limit from the right. So limit from the left, so that's x approaches 2 from the left, so 2 minus of f of x. From the left, it's this branch, so that's ln 2. How about limit from the right? That's this branch, okay? So that would be 4 ln 2. Limit from the left does not equal to limit from the right. Limit does not exist. Okay. Graph of the function f is shown here. Has a vertical tangent at the point 2, 0, and horizontal tangents at the point 1, -1, and 3, 1. For what values of x is between -2 and 4, is f not differentiable? Remember, there's 3 cases where a function is not differentiable. Okay? When there's a sharp turn, like the absolute value function, because derivative from the left does not equal derivative from the right. Okay? When there's a vertical tangent, so immediately we know at this point, okay? Because there's a vertical, it says there's a vertical tangent there, because the slope of the tangent line is infinite, right? And also when it's discontinuous, because we can't find the limit, okay? So at 0 also, it's another point where the derivative does not exist, so it's 0 and 2. Okay? Particle moves along the x-axis so that its position at time t is given by this. For what value of t is the velocity of the particle 0? To get velocity, we need to differentiate x. So let me do it up here. V of t is x prime of t, okay? So we just use the power rule, 2t minus 6. It asks us when the velocity of the particle is 0. So we set this equal to 0. We can clearly see that t is equal to 3. Oh, this is easy. If f of x is this guy, f prime of 2 is, well, what's f prime? Capital F prime? That is fundamental theorem calculus. We just plug in the limit. Okay? X cubed plus 1. Okay? And now we evaluate this at x is equal to 2. As simple as that. So this is square root of 8 plus 1, which is square root 9, which is 3. That's D. Okay, if f of x is sine e to negative x, f prime is, this is just testing the chain rule. We go outside in. Cosine is derivative of sine. Okay, then we differentiate the exponents. That's just e to minus x. And then we differentiate minus x. That's just negative 1. Okay, so we have negative cosine e to negative x times e to negative x. So that looks like e. Okay, we're moving along. Graph of f is of a twice differentiable function f is shown here, which the following is true. It asks about f of 1, f prime of 1, and f double prime of 1, okay? Well, we see that f of 1 is 0, okay? What's f prime? F prime is slope of the tangent line. That's some positive number, so that's all we care about, actually. So let me just write positive number, okay? Now, f double prime, that's concavity. Is this curve concave up or concave down? It's concave down. So f double prime of 1 is some negative number. So now we have the relationship. F double prime is the smallest, f of 1 is 0, and f prime is the biggest because it's positive, okay? So f prime is the biggest, so it looks like D. Simple as that. Equation of the line tangential graph of y is x plus cosine x at a point 0, 1 is, we want the slope of the tangent line first, so we need to get derivative of this guy. Y prime is 1 minus sine x. Okay, we evaluate this at x is equal to 0. Why is that? Well, that's where our tangent, where the point is. We want the tangent line at that point, so that x is equal to 0. Okay, which is 1 minus 0, which is 1. Okay, so that's the slope. We have a point. We can use point slope form. Y minus 1 is 1 times x minus 0. So we can write it as y equals x plus 1. B. F double prime is this guy. Then the graph of f has inflection points when x is equal to what? So we got to do the second derivative test. They gave us the second derivative, and we know the critical points are x is 0, negative 1, and 2. Okay, so let me just squeeze it in over here. So negative 1, 0, and 2. Okay, we plug in some huge negative numbers, so some number less than negative 1. This guy's always positive because it's squared. Some negative number, some negative number. 2 negatives make a positive. Plug in a number in this interval like negative half. Again, this is always positive. This would be positive. This would be negative because negative half. This would be positive half. So the sign is negative. Plug in some number here like 1. Again, this is always positive. This is positive. This is positive. So the sign is positive. And you plug in a huge positive number. Everything's positive then. Okay. Points of inflection are when second derivative changes sign. So it's at here and here. Not here though. So only at negative 1 and 0. Okay. And how many problems do I have left? We're at 20 minutes. Yeah, why don't I stop here? Okay, so please like this video if you found it helpful. And please subscribe to get notified for the next video, which is me finishing up these problems.